SpaceX AI posted Grok 4.5 on Wednesday afternoon as a model trained for coding and agents. Cursor's Michael Truell amplified it almost immediately. Elon Musk followed with a note about C and C++ inference work and GB300 hardware targets. TryAI then put Grok 4.5 into a build-off against GPT 5.5 and Claude on the same app tasks. So the lead today isn't just another model name on a leaderboard. It's a coding release arriving with an editor relationship, an inference story, and a first round of practical app-building comparisons.
The cursor connection changes how I hear the announcement. A model trained for coding can mean a lot of things, but a model sitting close to an editor has to answer a sharper question. Does it keep its bearings while a project is changing under it? A prompt window function is an easier job. In the editor, the model has to notice files, respect conventions, survive tool calls, and not become weirdly confident after it takes one wrong turn.
Right, and the launch reads better through artifacts than through the Elon replies. The SpaceX AI post is the artifact. SpaceX AI aimed Grok 4.5 at coding and agent work. Truell's post matters because Cursor is one of the places where that claim becomes concrete. Musk's infrastructure note matters because speed and cost in an editor aren't cosmetic. A coding assistant that feels brilliant for 10 seconds and then stalls for a minute is still a bad daily companion.
And the cost part isn't a footnote for coding agents. If the model is going to browse a repo, run tests, inspect logs, and make repeated edits, a single user request can become a small swarm of calls. That makes the product feel less like a chatbot subscription and more like a metered development environment. The model can be clever, but if it burns too much money or waits too long between steps, people will reserve it for special occasions.
TryAI's build-off sits at exactly that altitude. It isn't the final word on Grok 4.5, GPT 5.5, or Claude. It is a practical comparison. Give the models the same app-building jobs and see what happens. I like that kind of artifact because it is closer to the way people meet these systems. You don't meet them as a benchmark score. You meet them as a half-working app, a patch that almost compiles, or a UI that missed the obvious state.
App build-offs also smuggle in a funny social test. People forgive different failures depending on the model's personality. A model that is fast and a little sloppy gets called energetic. A model that is slower and more deliberate gets called reliable until it misses something obvious, and then it gets called overcautious. The app gives you evidence, but the experience of watching it work colors the evidence.
Coding model launches have this awkward property now. The model is judged as a worker, not only as a solver. People ask whether it noticed the spec, whether it kept the file structure intact, whether it recovered after a failed test, and whether it explained itself in a way that made the next human move easier. Grok 4.5 may turn out to be excellent there, or uneven, or great on some stacks and strange on others. The first day tells us the market is treating coding as its own frontier lane.
The daily driver slot matters here. Not every model needs to become one, but coding models now compete for that slot. The daily driver model doesn't have to win every synthetic task. It has to be the one you keep reaching for after it has annoyed you twice and saved you 3 times. That is a much more human test than the launch copy can capture.
And it is why I would keep the first read modest. Grok 4.5 is a serious new entrant in the coding agent lane. The exact ranking can wait for more third-party runs, more repo-level trials, and more evidence from people using it inside real work. For today, the frontier model race has another model aimed straight at the editor. The comparison set now includes Grok, GPT, Claude, and the cost of letting any of them touch a project for a long stretch. OpenAI also posted an 18-minute demo of GPT Live 1 on Wednesday evening. The important detail is the interaction model. ChatGPT voice listens and speaks continuously, handles interruptions, and can hand harder reasoning or search work to a stronger model tier while the voice interaction keeps moving. After yesterday's GPT 5.6 access fight, this one sits at the interface layer. The user experience is starting to look more like a live conversation loop.
Full-duplex voice is one of those phrases that sounds dry until you imagine the old version. The old voice assistant makes you wait your turn. You speak, then it stops to think before it speaks back. If you interrupt, you feel like you broke the ritual. A continuous model can treat interruption as normal input. That matters because humans interrupt when they are confused, excited, impatient, or trying to steer.
Exactly. The demo's delegation piece also matters. If the voice model can keep the conversational tempo while sending harder work to another model, then voice doesn't have to choose between quick response and deeper reasoning in the same way. You can imagine a lightweight loop that keeps listening, asks clarifying questions, and then pulls in a stronger reasoner when the task earns it.
That makes the model feel less like a single brain and more like a small production crew behind one mouth. Chuckle. I don't mean that as a product slogan. I mean the user hears one assistant, but the system can be routing work behind the scenes. Quick speech handling here, search there, and a stronger reasoning pass when the user's request stops being casual.
Voice demos can make everything look solved because the surface is so persuasive. A smooth interruption, a natural pause, a little recovery after crosstalk. Those details create trust quickly. But the system still has to keep track of commitments, sources, and state once the conversation gets messy. A voice agent that sounds present can still forget why you started talking to it.
And people will test it in messy ways first. They won't start with a perfect command. They will talk while walking around. They will correct themselves mid-sentence, change the goal, ask it to search, and then remember the constraint they forgot at the beginning. If GPT Live 1 handles that well, the interface stops being a novelty and becomes a way to think out loud with a computer.
I like keeping this segment separate from the model access story for that reason. OpenAI's recent releases have had a lot of permission drama around them. GPT Live 1 is more concrete. Can a voice interface sustain a conversation while the system routes different kinds of work behind it? The demo says OpenAI is trying to make interruption, delegation, and live turn-taking part of the product, rather than a party trick.
It also changes which failures feel acceptable. In text, you can skim, undo, or ask for a correction. In live voice, the failure enters your room. A wrong answer spoken confidently while you're trying to cook, drive, debug, or teach someone feels more intrusive than a wrong paragraph on a screen. So the interface win raises the bar for recovery. It has to say, in effect, I heard the correction and I am back with you.
And that recovery behavior may be the product. The product isn't the accent, the latency by itself, or the demo charm. It lives in the assistant's ability to take an interruption without becoming brittle, ask a follow-up without derailing you, and pull in search or heavier reasoning without making the conversation feel like it went through a trapdoor. OpenAI posted that it no longer recommends SWE-Bench Pro as a reliable measure of frontier coding ability, and the reporting around the item says OpenAI found about 30% of the tasks broken. TechMeme picked up the retraction. Around the same time, Databricks published a benchmark on its multi-million-line codebase, and the AgentLens paper describes an evaluation that scores the whole trajectory of a code agent's run.
That combination feels more important than any one score. A coding agent benchmark can go stale in two ways. The models can get better, which is the happy version, or the tasks can turn out to be broken, ambiguous, contaminated, or too far from how the tool is used, which is the more embarrassing version. 30% broken isn't a small caveat if you were using the benchmark to make procurement or product claims.
The AgentLens abstract says the measurement problem in plainer language than most benchmark papers do. Most code agent benchmarks reduce a run to 1 bit. Did the task pass? AgentLens argues that people experience the whole trajectory: instructions, tool use, verification, mistake recovery, and the agent's communication along the way. It pairs formal checks with large language model-written trajectory reviews and side-by-side comparisons, so the score comes with a readable explanation.
That matches how annoyance works. A code agent can pass at the end and still waste your afternoon. It can take a reckless path, ignore a convention, produce a patch you don't trust, and then somehow get the green check. If the benchmark only sees the final check, it misses the experience the human had to live through.
Databricks' contribution is the production codebase angle. A multi-million-line codebase brings different pressure than a cleaned-up issue set. There are internal conventions, dependency edges, flaky tests, ownership boundaries, and the simple fact that changing one file can mean understanding 5 nearby systems. A model can look strong on small, isolated tasks and then become expensive in a codebase where context isn't handed to it neatly.
And the funny part is that this isn't anti-benchmark. It is pro-benchmark in a more adult way. If the task set is broken, fix it. If the final pass bit hides bad behavior, add trajectory review. If a model looks good on public tasks, test it against a codebase with real history. The problem isn't measurement. The problem is pretending the scoreboard measures more than it does.
The Grok launch and the SWE-Bench Pro retraction touch here without becoming the same story. A new coding model needs a way to be understood. Benchmarks are the first language the market reaches for. But as soon as models become agents, the unit of evaluation gets longer. It isn't just answer quality, it is root quality. Did the agent inspect the right files? Did it verify the change? Did it recover when a command failed? Did it ask for help at the right time?
Root quality is also where product teams can fool themselves. A beautiful demo path can hide a lot of awkward behavior. The agent might be excellent when the repo is well prepared and the task is phrased exactly right, then fragile when the issue is vague or the test suite has local quirks. Trajectory-based evaluation makes those quirks visible. It gives you a transcript of judgment, not only a trophy.
OpenAI retracting a recommendation is also a useful cultural act. Labs have incentives to keep citing the numbers that make their models look good. Saying a benchmark no longer holds up creates some short-term discomfort, but it gives everyone permission to talk about task quality. And if coding agents are going to touch more real code, that discomfort is cheaper than trusting a benchmark after it has stopped describing the work.
The next generation of coding agent evals will probably feel less elegant. They will have logs, reviewer notes, replayed tool calls, and maybe nightlies that catch regressions in how the agent behaves. That is messier than a leaderboard. It is also closer to software. Software quality has always lived in the trace: the commit, the test, the review, the incident, and the patch after the incident. Agents are just making the trace talk back.
AgentLens even says it uses the benchmark to compare successive versions of its own agent and catch product regressions in a nightly evaluation pipeline. The nightly regression line is the most grounded line in the abstract for me. The benchmark isn't only a public contest, it is a way to notice when a new model or agent build got worse at following instructions, using tools, verifying work, or explaining itself.
That is a nice inversion. The public wants a rank. The product team wants a smoke alarm. Those aren't the same object. A rank is simple enough to argue about online. A smoke alarm has to wake you up when a release broke a behavior your users depend on. If coding agents keep getting deeper access to repos, I care much more about the smoke alarm.
So the benchmark story today is simpler. Coding agent measurement is becoming a product discipline. Broken tasks and production code bases both push the same adjustment. The test has to watch the agent work through trajectory review and nightly regression checks, because the work is no longer a single answer. The infrastructure update today is narrower than the late June Power episode, and better for it. TechMeme has an item on Power Transformer lead times. It also has Meta's 1 gigawatt, $9 billion Alberta data center plan, coverage of Iluvatar Core X in the Chinese GPU market, and a funding item around positron. These don't add up to a grand theory. They show compute expansion running into equipment, geography, and capital.
Transformers are a wonderfully stubborn lead item because they don't care about model roadmaps. You can announce a better model, raise money for chips, lease land, and still wait on the heavy electrical gear that lets the site draw power safely. That makes the infrastructure race feel less like a spreadsheet and more like a construction schedule with a global supply chain attached.
Meta's Alberta plan puts a number on the geography side: 1 gigawatt and $9 billion. Alberta isn't an arbitrary place in that sentence. Data centers follow power, land, cooling, permitting, and political appetite. The AI boom often gets narrated from San Francisco product desks, but the capacity appears in places that can host the machines and the grid work.
And the chip capital items show the same pressure from another angle. Ilavatar CoreX sits in the Chinese GPU story, where domestic capability matters because export controls and supply access matter. Positrons raise points at a market that still wants alternatives around inference hardware. None of these items alone explains the compute economy. Together, they show how many bottlenecks can be monetized at once.
Keeping it proportionate helps here. The transformer item doesn't mean GPUs stopped mattering. The Alberta plan doesn't mean every data center project works. A Chinese GPU maker's stock performance doesn't mean domestic substitution is solved. A positron funding round doesn't mean NVIDIA has been displaced. These are updates from different layers of the same build-out, and each layer has its own delays.
The human part is that every delay creates a new center of negotiation. A utility has leverage. A transformer supplier has leverage. A province or municipality has leverage. A chip vendor has leverage. A cloud buyer with a giant reservation has leverage. The model lab may be the famous actor, but the schedule belongs to a much larger cast.
This also changes how I hear promises about cheaper intelligence. The software curve can improve quickly, but the physical curve has procurement and installation times. If inference gets more efficient, that helps. If demand grows faster than efficiency, the power equipment still matters. The transformer lead time story is a reminder that a cost curve has a warehouse somewhere inside it.
And a permitting hearing, and a maintenance crew, and someone deciding whether the local grid upgrade is acceptable. Infrastructure stories are easy to flatten and easy to misunderstand. The interesting part isn't that electricity is scarce in some abstract sense. It is that every model improvement produces new choices about where to put machines and who absorbs the disruption around them.
So I would file today's infrastructure cluster as a concrete update, not a new thesis. The boom is still constrained by GPUs. It is also constrained by transformers, sites, political acceptance, local grids, and the capital markets willing to fund alternative chips. The model story keeps becoming a place story. Alberta, Chinese GPU vendors, transformer suppliers, and inference chip startups all belong in the same notebook, but not on the same line. The agent infrastructure cluster is smaller, but I like it because it is practical. Latent Space interviewed Modal about cloud primitives behind elastic inference and agent sandboxes. AI Engineer posted an OpenAI talk on designing an agent sandbox cloud. AWS announced Claude Apps Gateway for AWS, a self-hosted way to manage Claude app access, cost, and policy inside an AWS environment.
This is where the word agent stops being magical. An agent has to run somewhere. It needs a file system or a simulation of one. It needs permissions, network boundaries, logs, and a way to spend money without surprising the person who pays the bill. A sandbox isn't a side feature when the system can take actions. It is the room the action happens inside.
Modal's angle is interesting because elastic compute has always been about giving developers capacity without making them own the machinery. With agents, the capacity question gets weirder. You may need short-lived environments, parallel tool runs, isolated execution, and enough observability to figure out what happened after the agent exits. That is cloud infrastructure, but with a much more restless workload.
The AWS Claude Apps Gateway is the enterprise version of that same anxiety. Companies want the model, but they also want a place to put policy. Who can access it, what it costs, which app is allowed to call it, and how usage gets governed. The Gateway product says the model isn't enough for enterprise adoption. The access layer becomes something people buy or build.
Construct covered a related idea in late June, Claude becoming a procurement bundle. Today's AWS item gives that idea a product surface. Instead of saying the contract and meter matter in the abstract, AWS is offering a gateway where access, policy, and spend control live close to the customer's own cloud.
There is a subtle power question there too. If the control plane sits in AWS, the enterprise gets comfort, Anthropic gets another path into corporate usage, and AWS keeps itself between the buyer and the model provider. Nobody has to be villainous for that to matter. It is just how a market starts arranging itself when trust, billing, and identity become valuable places to stand.
The OpenAI sandbox Claude talk points to the same engineering center of mass. Once agents can run code, browse, call tools, or operate inside a repo, you need a design for what they can touch. Sandboxes are how you make experimentation less dangerous and production behavior inspectable. They also become part of the developer experience. If the sandbox is slow, opaque, or too restrictive, the agent feels worse even when the model is good.
The practical claim from this cluster is simple. Agent quality is partly environment quality. A weak sandbox makes a strong model stumble. A good gateway can make a cautious company comfortable enough to try the system. Elastic compute can make an agent feel available at the moment of need. The intelligence is in the model, but the confidence is in the room around it.
And this isn't one coordinated launch, it is 3 adjacent artifacts. Modal talking about runtime primitives, OpenAI talking about sandbox design, and AWS packaging Claude access control. The lesson is practical enough to avoid overdrama. Agents are leaving the demo box, and the products around them are starting to look like execution environments, policy layers, and cost controls. The policy update is short because yesterday already went deep on GPT 5.6 access. CNBC reported today on AI companies spending through industry packs while lawmakers work on AI legislation. Nathan Calvin also posted about government clarification around model releases, and CNBC had the related report on OpenAI getting US regulatory approval for GPT 5.6. Andrew Curran pointed to OpenAI's national security principles as part of the same public argument over release authority.
The Packy story gives us the newest piece because it isn't about one model. It is about how policy gets made around the model market. Companies can publish principles, negotiate release permissions, brief lawmakers, and spend money through political channels. Those are different instruments, but they all try to shape who gets to decide what can be released, under what conditions, and with which penalties if something goes wrong.
And that is where I would separate the two stories. The GPT 5.6 approval and clarification items belong to the release authority fight we covered yesterday. The election spending report is about the next layer out. If AI legislation is coming, companies aren't going to wait politely for it to happen to them. They will try to influence the people writing the rules.
That can sound cynical, but it is also ordinary politics. The unusual part is the pace and technical opacity of the subject. Lawmakers are being asked to reason about models and national security while also handling copyright, labor, competition, energy, and consumer risk. The companies with the best lobbyists and the most fluent technical briefings will have an advantage before a bill even has language.
OpenAI's national security principles matter in that environment because they aren't only internal values, they are also a way to describe responsible release in public. A principles document can reassure regulators, set expectations with customers, and create a vocabulary for why a company should be trusted to make certain calls. The hard question is what happens when the business incentive and the principle point in different directions.
That is why release authority keeps recurring. By the time a model launches, the technical artifact travels with an access plan, a regulator conversation, and the political economy around future rules. If a lab says it can release responsibly, the next question is who audits that claim and who benefits when the answer is yes. That question doesn't get resolved in a launch post. It gets fought through filings, elections, agency pressure, and public trust.
So today's policy note isn't a rerun of Wednesday. It is the wider machinery becoming visible around the same kind of event. Model release permission is one fight. AI legislation is another. Campaign spending, public principles, and government clarifications are the methods people use before the rules harden. So the day starts with Grok 4.5, but it doesn't stay there. A coding model arrives, a voice interface gets more conversational, a benchmark gets publicly questioned, a paper says evaluation should watch the whole agent trajectory. And infrastructure stories keep reminding us that models need power equipment, sites, sandboxes, gateways, and political permission around them.
What I like about that lineup is that none of it lets the model stand alone. Grok 4.5 has to be understood inside editors and cost curves. GPT Live 1 has to be understood inside interruption and delegation. Coding agent evals have to inspect behavior, not only outcomes. Infrastructure has to include transformers and geography. Agents need rooms to run in. Policy decides who gets to open the door.
The next evidence I care about is plain. For Grok 4.5, I want repo-level accounts from people who used it for more than a demo. For GPT Live 1, I want messy conversations where the user interrupts, changes goals, asks for search, and comes back later. For benchmarks, I want task audits and trajectory traces to become normal parts of a model claim.
For the infrastructure pieces, I care about which announced sites turn into powered capacity and which alternative chip companies get real workloads. For the policy pieces, national security principles have to become operational commitments, or they will remain public language during a lobbying fight. The public artifacts today are enough to ask those questions without pretending the answers have arrived.
On Thursday, July 9th, the coding model race is moving fast, but the tests, voice loops, sandboxes, power gear, and policy machinery around it are now part of the product people are buying. The model still matters first. The trace around the model is starting to matter almost as much. Lenar Kess.